and we're good. All right, so as I was mentioning, we're going to start putting those together today. So I have my previous model, just as abstraction, sculpture-esque, right? We definitely have our columns. Maybe it doesn't have any floors yet, but it's okay. We can definitely put those in. The next thing that I need to do is maybe import my stairs. I went ahead and imported, well, I just made this right now. Just made a quick topography model. You know, using that cardboard method we talked about last time, essentially just extruding each piece and, you know, more or less pretending that this is cardboard at a certain thickness. The next thing that I want to do is actually import my stairs, and there's a couple ways to do that. I can just open up, honestly, Rhino at 2 different times, right? So like example stairs, and you can have 2 Rhinos open. Now, I don't recommend that for a lot of computers because that's a really good way to freeze your computer, but in our case, it's working okay. And probably the easiest way is to Command C or Control C if you're on Windows and paste it, right? It's going to be the exact same size, the exact same units, and all kinds of things. So that's not too hard. Another way to do it is, of course, to go to File, Import, and you can import that 3-dimensional stair as well. And it's going to actually be in the exact same spot, right? Because, well, it's based on the exact same spot that it was via your C-plane. So you'll find that if it was way out in the distance, it's also going to paste way out in the distance, right? So just kind of be aware of that. But I can close that for now, don't need it, where it changes. And of course, there's a model from last time. But yeah, now we definitely have all of our pieces. So keep in mind, I definitely want to finish the process first. So if you're still working on the stairs, that's fine. Finish your stairs, right? Because as soon as you start putting all of these together, things get a little bit more complex. I'll definitely have to start being more organized with my layers. I'll separate rails, floors, ramps, stairs. And to be fair, if I did that in the other file, it'll bring in those layers too, which is really nice. So again, being organized eventually pays off when you're trying to go for speed in Studio, which is kind of the name of the game here. So we have our topography, our model, and our stairs, and essentially we just need to put them together. So one of the easiest things to do is, of course, group them. I'm going to group my main pieces because essentially what I want to do today is make a digital model, right? I want to get it as close as possible. That way I have some sort of trinket, if you will, or, you know, sort of asset to not exactly copy because, well, some things will technically have to change in order to make them. But you'll see what I mean. We'll definitely want something to go by. You know, just as much as we have a physical model on the table right now that we can look at, we want a digital model that we can look at too and observe without maybe necessarily having to spend money yet creating it. So I'm going to go ahead and group these 3 parts. So I have my topography, my model piece, and I want to get my stair. And the reason I'm grouping them is, well, you know, I don't want to accidentally lose a rail or lose a baluster. Something that I think I forgot to talk about last time was making little balusters. However, I think it's also kind of self-explanatory. Make a pipe, a pole, draw a line, pipe it. There's a lot of different things we can do for balusters. But yeah, if you can make a rail, of course you can make the vertical baluster part as well. But let's go ahead and group that. So this is a stair I made last year, and as you can see, I've already made some changes to it. Actually, to be fair, let's ungroup that and get rid of some of the strange anomalies. We'll add those actually per our model. And there's kind of just like random stuff in the air. So maybe want to clean it up. Maybe I had a hard time. Yeah, this is when I made a lot more mistakes to show you guys how to fix stuff. And anyway, you guys are so good at it, I don't have to show you too many mistakes. So again, let's group that back and essentially put them together. So you can really let that be up to you. I really prefer the top just because they're all on the same plane. I'm going to go ahead and actually make a copy because you'll see why. We're going to start chopping away from this model as well. It's okay, I have step 1 in there. Didn't really need that piece, but that's okay. Next, I'm going to put my model, so I'm going to make a copy. And again, it's just so I mess up, and to be fair, I can make this like 3 different times. I could try it this way, I could try it that way, I could do all kinds of things, right? So don't get me wrong, you can still iterate and find the best way that works for you. In our scenario, it really lacks a lot of limitations, right? Such as, we don't have to worry about the design so much or what it's facing, the sun path. A lot of the normal things that we would totally worry about in studio is not our focus for today. Really, keep in mind the focus for today and really this project is just a well composed and accurately crafted object, right? So just keep in mind it's not going to get the same kind of critique that you would in studio, right? It's definitely much more about the tools. So we could do something like that. I don't really recommend it just because, well, it's going to make it really hard to use gumball and things like that. It's something that I could also do at the end to rotate it or even rotate the ground a little bit. I think would be easier than rotating the actual model. But you can get fancy with the spices. Next, we need to put our stairs in there. So I probably need to group those back again. And it looks like I have that piece back. Oh, that's because I made a copy. There we go. So there's the one I want. Let's go put the stairs with the other copies. And we'll put this to the ground. And we'll go ahead and line this up first, actually. Why not? One of the first things, of course, are foundations. I mean, definitely the most important. The building's got to stand. And right away you see that we're going to have some issues. I either have to lengthen these poles, and that's going to lengthen the whole observation tower. I might not actually have the budget for that. So obviously it's going to need to go into the ground somehow. That's looking pretty good. You'll see that some of the parts, however, really chop into the topography. So two things can happen. We can either chop away from this piece when we laser cut it, or we can cut away from the topography. That way we can inset these pieces into the ground, something that's a little bit more realistic to what would actually happen in real life. Now, to be fair, this isn't dirt. This is just random zeros and ones. So there is a little bit that we have to sort of give our insight into and start to imagine, okay, if this is the ground and I'm making a concrete wall, I can't cut a concrete wall, right? If anybody's tried to cut concrete, it takes a lot of energy, right? It makes a lot more sense that I would dig a certain portion out of the dirt and of course slip it in there. So, using those kinds of practices and keeping that kind of thing in mind is a good idea. But so far so good, definitely got some poles hitting the ground, almost in some cases. Maybe it needs to go a little bit deeper. So I'm gonna raise that a little bit more. And to be fair, if I really want to make sure, and I don't know, maybe I want to get that base just all the way down. I kind of like this little floating box though, so I think I'm going to keep it. Plus it's a pretty interesting space in there. And I don't really see it coming out the other side, so even if it did, not a big deal. I can show you what to do for that. I want to see it in ghosted, so I can kind of see where those poles are. Yeah, and man, they're like almost there, touching it. Not too shabby. So we have that pretty solidified. Next thing we can get in there is the stairs. So in my case, this stair might not exactly work for, obviously I designed it at 2 different times, but that's realistically what I want you to figure out as well. There's a reason why I didn't have you design the abstract so well, right? Is because, well, now the stairs are important and we have to cut away from the abstract model to make the stairs work, right? Not the other way around. The stairs are kind of solidified, and as you guys are slowly finding out, you have to calculate it a little bit, right? At least in terms of numbers, and figuring out, kind of the complexity that you want with the stairs or the circulation. But as you can see right now, I see a lot of potential. So let's take a look. We got the stairs here, and again, this is a really good idea that we grouped everything. That way I don't have to try and select these stairs inside of this very complex model. But hopefully you kind of see where it's going, right? So we might have to imagine a little bit, right? Where are the stairs going to come through? Maybe I align this stair actually to this wall. That makes a lot of sense. And there's opportunity to make that structural. In our case, it just means that we're going to have a plane that we can glue our stairs to. We all know that, especially if you've made a model before, you can't just have stuff floating in the air. However, in a Rhino model, of course you can. You can do whatever you want. You could have thousands of things in the air, and it doesn't really have to abide to gravity or anything like that. But in our case, let's get it close. That way we can at least start to see what we need to take away from our abstract model. And that's actually working really well there. Maybe not so much there in the hole, so let's maybe push that a little bit here. Let me get it on that side. but it's actually aligning to some of my walls kind of crazy, especially since I didn't design those together. But that's looking pretty good right there. Oh, it looks like we're gonna have to chop a little bit of wall away, not a big deal. And it definitely looks like we might have to get rid of this floor or maybe wire cut it away. You know, some pieces we'll keep, some pieces maybe we can chop away. But this is definitely going to take a little bit of time, and not for a bad reason, just because, well, we definitely want to do this here before we actually spend money making it, right? So of course, we want to dial this in as much as possible, and really start to consider it as if we are going to make it. So to imagine what some of these pieces may be. Obviously, I think the topography, definitely cardboard for everybody, 1/16, pretty fair. I even think it says that on the instructions. But the rest is really up to you. All I'm asking for is really that the framing is basswood in some way. But to be fair, some students preferred chipboard, some students preferred basswood for their stairs, and I'll let that be up to you. I brought examples of both, so you know, not so much a focus on the material quality of things, but really just practicing, right, and possibly making something for studio. But as you can see, we have a lot of areas where we need to take away. So let's go ahead and do that. I'm going to go ahead and lock my stairs into position, just so I don't accidentally lose that piece. To be fair, I'm also going to make another copy because I don't want to accidentally lose that, and I know from what I'm about to do right now that I may want to go back. So I'm going to start taking away from this model, but if I accidentally take away too much and go too far, again, at least I have a backup copy and I don't have to realign anything like that. So next thing I'm going to do is maybe actually lock my topography in place. So we'll go ahead and lock that. It'll even change color. And in my case here, I'll go ahead and ungroup that. And really just kind of walk the stairs, right? So first things first, I have my stairs hitting the topography. That's not such a big deal. I mean, it would be kind of a hard place to get into, and of course Professor Tunks would not approve. But, you know, it's definitely something we can work with. We can start to take this floor piece back, and to be fair, it almost looks like we don't even need it. I don't know, what do you think? Obviously, we don't have to just start getting rid of everything. So maybe we actually make it a part of something. It seems to actually line up with some of the steps. And basically all I did was shorten it, right? So I'm basically want to test and make sure that I can still use it, still see it. Does it still work? And in my case, I think it does. I just need to maybe move it and manipulate it just a little bit. I'm going to go ahead and move it and maybe align it with something with my stair. Why not? Maybe it works, maybe it doesn't. I guess I am in an kind of a hard mode to look at. So let's get, yeah, there we go. And as you can see, if you've ever run into this issue, it's basically because those two faces are literally on top of each other. They occupy the exact same space. They break Newton's second law that two objects cannot be in the same exact space at once, right? Which again makes the digital realm a little bit more difficult. But in our case, I can dial it back a little bit, and maybe that starts to be support in that region for that stair. Not a big deal. However, we can't have poles going straight through it, so something's got to happen. And to be fair, I don't need necessarily all these poles or columns. So I could decide to move that grid a little bit. Maybe I do. So I can take all four and scooch it. Right? Maybe I align it with the wall in some case. Not too shabby. It makes a lot of sense for this part of the stair now. Now I got something, of course, holding that up. But as you can see, this is going to take a little while, right? Going through every single one of my stairs. Right off the bat, you know, I've got something in the way of my stair there. I could decide to lift it, right? Maybe it actually becomes a problem for something else. As you can see, this is going to be quite the puzzle, right? And intended to be so. Maybe it just needs to be a little bit shorter. It's really going to put our manipulation tools to the test, right? That's looking like it's working so far. Looks like we have another piece there. Yeah, and that one is actually pretty big. So let's take that one down a little bit. Another option too is, well, you know, maybe I don't want to move that, right? That's actually looking really nice, and actually I like the position that it has with the ground, so I'm going to make it even longer, right? Well, what do I need to do? Probably cut that out. right? So let's start with a rectangle, then wire cut it and see what happens. May need some more views, and I may need to actually hide some stuff just because I have so many copies. I think that's the one I'm working on, yeah. Well, let's go ahead and hide those as well, just to make it easier for myself to look at. And I can start to go, hey, what's going on here, right? Things like that. Oh, it's my stair. What do you know? Obviously going to have to chop off some things, or maybe I should actually rose my stair a little bit more. Anyway, obviously this is a tutorial. Please don't copy my mistakes, right? Really, it's to get more familiar with the tools. But let's wire cut that out, right? I know it's in this general area, and to be fair, I could go to wireframe mode or a ghosted mode so that I can start to go, oh, okay, yeah, it was definitely in that air, and it was definitely that piece, or what piece was it? That piece. Okay, so definitely in this area. I'm going to go ahead and draw a rectangle, just sort of freely, right? Because I can always control that, make it a little bit smaller, bigger, whatever's needed. Get in the general area and make sure that it's outside of the object that I want to cut. I can also cut from multiple items, right? But that's looking pretty good, and I think it's going to get this out of the way. Make sure it goes all the way down so it gets that little piece. Let's try it. Wire cut. Click on the piece we want. Now, something I've noticed is you can actually change the direction of your wire cut, so just be mindful of that. And it does go back all the way to Rhino 7, so that's nice. And as you can see, I'm in the wrong direction, so let's go to X. To be fair, sometimes you don't know which direction you're at, and that's okay too. I only want to cut a little bit of it, or just enough to actually get to the stair, so I don't know, maybe I align to actually the stair, right? That way I know that it's going to cut only to the portion of the stair. So hopefully that makes sense. And it even starts to give us a preview. Hey, did you mean this piece to go away? Absolutely. Enter. And now we've freed up our stairs, right? As you can see, we also have a pole going right through the middle. And we have a few of them. So, well, I might just need to move that grid. Or make it closer to a rail. Looks like got one in there. And we'll move it off to the side a little bit. But yeah, now we can start to think, well, I can definitely glue my stairs to those columns. Next we have in the way is our rhythm piece. So I'm just gonna naturally get rid of some of those. I don't want to get rid of all of them though, because I mean that's a nice artistic spot that somebody could totally sit down or put a drink on before they're about to run, or I don't know, it's definitely still a feature of my observation tower, so I don't want to get rid of too much. But obviously I do want to be able to at least believably walk up these stairs. May want to get a scale figure in there or two. And maybe get rid of that one as well. Maybe make some nice space up there. It's pretty interesting. But it definitely looks like I can walk with maybe out hitting my head so much now. And it looks like I do need to dial that back just a little bit more. But yeah, now we're starting to get somewhere. All right, let's keep going. So as you can see, I had to cut away from the stairs at some point. Please don't just randomly cut your stairs. But that's looking good so far. And you kind of have to stare at these pieces a little bit and go, okay, what's going to have to happen for this? Do I need to chop that away? Is that something that I could just do in the physical life, right? I mean, because that's something I could just line up to the cardboard and cut it off manually with an X-Acto blade. However, if I wanted to be more specific, I could Boolean difference these two pieces. That way I can get an exact object for that piece. And that'll make sense in this next portion. So, continuing on, let's get the rest of the model. We got a really funky spot here. It goes up to a landing and then goes over there. So I may want to, of course, find that spot a little better. And again, wire cut it out. I can even use that same wire cut piece and get it to a spot that makes sense. Usually I like to get it towards the stairs so I can kind of start to visualize it a little bit and kind of see that, oh yeah, I need to remove from that piece, I need to remove from that piece. Let's do them at the same time, or try to anyway, why not? So I definitely want to take it from stair to this portion of the stair. So wire cut, let's go ahead and get that piece and that piece, enter. In my case, I do want to make sure that it goes through. Sweet. Enter. And it's definitely working for that spot. Works for this landing now, and it looks like it's nice and snug in there. Maybe I actually move some of these panels a little bit. And again, this is really going to start to test your view of three-dimensional space, right? So if you use color, sometimes that's definitely helpful, right? If you have different colored layers and you can really start to tell the difference between objects and pieces. However, you should actually know your abstraction better than anybody else, right? Now, in my case, I made it up on a whim, and it was for the sake of tutorial, so I didn't really spend a lot of time with it. So this might be a longer process for myself. But we're getting there, right? Definitely start at the beginning, go up, go through, landing, landing. And it looks like we should have gone a little bit further through this object, so let's keep going. Wire cut. Let's go through this one now. Straight through. Just go all the way. Right? Fantastic. And we have this really cool interlocking now within our abstraction. Again, we're not looking at the design, but my goodness, it's starting to make some pretty cool abstract space. Goes to this landing, hits that wall, sweet. Maybe goes up this, up, we got some columns in the way. Let's see if we can go ahead and get that grid. Sweet. And this is definitely where I wanted to start to mention that we can start to get some floors. Now, they're not real floors, but you can almost imagine that your landings need something, right? And in some cases, you might not have a whole lot of objects. So we may need another grid system. And thanks to Le Corbusier and his domino house, we have the freestanding plan. So for the sake of ease, I'm just gonna actually copy some of these. However, we'll make them the exact same way, but in the horizontal direction. So in my case, I just want to make a copy. That way I can rotate it. And start to show you more or less why we would need these horizontal pieces. So of course, copy. And slice that back in there. Now, of course, that's something you'll definitely see in these models. Probably way too many, because this came from the Confused Studio from having to make floors. So I decided to add them a little bit later during this process because, well, in some instances I may need them, and of course in most I may no longer need them. But for some reason my students last semester had a hard problem deleting stuff. It's like as if they sort of fell in love with the model perhaps too soon. But we can line it up to another existing pole, right? And we can dial that in pretty close. Now obviously, going from circular to sort of a cross pattern, I don't recommend it, at least making that physically, but boy does it make a pretty interesting, sophisticated model. But yeah, now we can use that to, of course, start to envision maybe how it holds up this stair. Does that make sense, guys? And of course, use as necessary. I could make it stick out. I mean, that is kind of cool. I mean, why not? Let's cap it. I see that there's not a solid object. But yeah, we can definitely start to use some of our horizontal grid systems to hold up other things. You know, I don't know, I'm kind of skeptical about this piece. I mean, maybe this is going to be enough to hold it up, but maybe I want something a little bit more. Or maybe that's just kind of in the way. Maybe I don't like it as much anymore. I'll delete it. Keep in mind, I do have a copy of it, so I know I have it hidden right now, but you know, just in case you accidentally delete something, of course there's always edit undo or that copied model that we have, so we can always bring it back in. Oh, thank goodness for edit undo. I'm always accidentally moving stuff. But yeah, I definitely want to make sure some of the stuff is locked into place, or at least that I can start to think about, man, how am I actually going to make this work? Right? And so maybe actually my stair sits on top of it, and that's not a big deal. I don't recommend having stuff go through your stairs, even though technically it's possible with the laser cutter, right? We can make these faces and we can have it cut out a little exact piece, and we can even interlock some of those pieces. But be careful, because if you guys have ever played with like impossible puzzles, or like they're like called usually mind teasers, and it's usually like a weird sort of thing that you have to pull out and get sort of a ring off of a string, or you know, usually some complex physical task. We can definitely accidentally make those kinds of riddles for ourselves. So be very careful. Just because it's possible in the digital realm doesn't mean it's necessarily possible in the physical. But we can get a ballpark, right? And to be fair, we can start to visualize, yeah, that pole's too long and too tall, or, things like that. Or maybe not long enough to, of course, reach that. So there we go. Now we have two columns, of course, holding this horizontal piece, and it intersects with this, so at least we know that there's an idea, there's something that we can work with there. I'm gonna go ahead and cap that just because I like closed objects. But yeah, it's really starting to get somewhere, right? We can almost imagine us going through it. I'm missing a few poles, and to be fair, we're not gonna make the rails. That would be insane, especially at this scale. Maybe if it was a larger scale, sure, but definitely not at this scale. So let's keep going. Looks like we're gonna need another hole. I can draw a new rectangle or use that one that I was using. Makes a lot of sense to use the one that I'm using just because, well, it already has a certain amount of dimensions that seems to be matching the stairs, so it's pretty good. And to be fair, I probably should do this in multiple views. That way I can start to align exactly where it is. Voila. And maybe I need to change the ghosted mode. Sweet. That way I can make sure that it's lined up with the piece. Maybe I want to make it look like it's floating, so I'm going to add a little bit of space towards the bottom of it. And maybe I do need it to actually connect to something, so I'm going to align my cut with the stair. Does that make sense, guys? Anyway, let's see what it does. Get it close enough. I'm going to make sure that it's, outside of my object. I just need it to cut through this portion of the wall, so wire cut. Take that piece. Oh, going the wrong way. Switch to Y. Slice it right through. Yep, looks pretty good. Enter. And voila, we can walk through there. I kind of like that, just kind of poking outside of the space. Might not be helpful eventually because, well, that stair might need some more support. So what can we do? Again, horizontal columns. Use them, please. Right? Don't just rely on making, of course, new planes or objects, because that may very well actually mess with the spatial components of the piece. So when in doubt, use Le Corbusier's method. Right? The freestanding plan is known as the domino house. You didn't think you were going to learn about some history of architecture today, but domino house. Definitely worth your time. Because it would be the reason why we have this system in architecture now. And since the 1920s. Really, architecture hasn't changed much, which is why we usually don't get a lot of research grants, but it is what it is. Now in my case, I'm making sure that I can connect to these two vertical and just intersect somewhere, and realistically, it's the easiest thing that we could probably do is put this stair on top of that basswood piece. Keep in mind, I'm starting to talk about it as a physical model, right? Sort of envisioning, that could maybe be basswood. And again, you don't have to make cross-section columns or anything like that. That was definitely for the sake of the digital model and to experiment with what we can do in the digital realm. But let's keep going. Fake it till we make it. Get it close enough. That's actually a pretty cool connection. A little bit long. But yeah, now we can definitely feel a little bit safer about how we're going to build or maybe make that work. But as you can see, a little bit of a tedious process. Right, we really do have to go through each piece, and depending on how complex you made your stairs, might be, how much you have to get away with. I'm thinking about Stevens. He might want to pick one of those stairs over the other. Obviously, put both in the model, but see maybe which one works more. Maybe which one I have to cut less, or maybe one just actually works better than the other. Some of us have multiple circulations, like Ed, right? So he might
do it over again.
No, don't do it over again. However, I'll let that be up to you, because to be fair, you know a lot more about stairs now. You might actually go, you know what? I just struggled for hours with this piece. I can make another one actually in 30 minutes now because I know what I'm doing, right? And I actually have a better idea of maybe where I want to go with this. Be careful with that because, designing stairs in this model space is a little bit harder. There's a reason I separated them for us, right? Because it can be really difficult, especially if it's your first time, to really do all this at once, even though you're expected to by year 3, right? So do keep that in mind. So hopefully we're making good habits with this anyway. But yes, technically you can restart your stair. But what I would suggest is, again, kind of going through the same motions. You just kind of do exercise 4 again, right? But I'll let that be up to you. But yeah, we need to continue. And let's face it, there's some easier changes than others. But I can't really move this anymore because, well, it's already locked into place in other areas. So I kind of have no choice but to wire cut it. Now, I can be a little bit more specific with my wire cut. And this is probably a good instance where I can do so. For instance, maybe I want my wall to actually be a perfect puzzle piece for this. So let's set that up. I'm going to, of course, want to pick the right view. So this is honestly probably the most challenge, is finding the view and really working yourself inside this model. I will say that's something that just comes with experience and practice. You start to get more familiar with three-dimensional space in the digital realm. And to be fair, you might not even have the view that you need, so you might have to actually rotate the camera. So setting the view, seeing if it's the front view, the back view, the left view, the right view, and we can't get all sides, which is why it was so important that I didn't spin my model in the beginning, right? Because if I did that, now I'm getting a diagonal view, which can be arguably much more difficult. You start to realize why curvilinear architecture and diagonals in architecture become much more expensive in the real world, because it usually leads to more complexity for either the digital user or the fabricator, right, in making all those pieces and parts. So there is a reason why we have box-like architecture in the real world. It's cheaper, it's less complex. However, if we can make this digital model and I can print out all the pieces, I can teach somebody how to put together a puzzle, and most people can put together a puzzle, right? So that's the way that I like to dive into it, and what we're going to be practicing with this digital model. However, I'm already 30 minutes in, so let's, for the sake of tutorial, say that I continued on this, and let's get that last wire cut piece. Let's finish that at least. So I can do this in free space, which sometimes I recommend. For instance, I can choose near, and like I said, guys, near is very dangerous. You don't really know what it's picking, right? But for the sake of what I'm doing right now, it's kind of the best of the world I got, right? So I definitely need to go down on this one, and I definitely want to get towards the stair. And I'm holding shift on this. That way it doesn't actually lock onto this piece, because as you can see, I'm locking onto that piece, but if you actually take a closer look at my perspective view, it's going way off into another spot, right? And that's not what I need. However, technically wire cut, it would probably work. But if I hold shift and actually move it straight, man, it's still trying to click to that. Well, let's see what happens. Enter. Where'd it go? Edit undo, because I don't want a random line in there. And maybe that's not the best way to do it. And as you can see, drawing in perspective is a very difficult task. So, what could I do? What could I do? Well, let's say the matter was really complex. I'll definitely show you what I would do. First of all, I'm going to unlock everything. And I'm going to take these two specific pieces that are in question and copy them and do it out here in free space. Make it easier for myself first, and then simply bring it back in. Actually, another way to do this a little bit more professionally is to take, again, the two pieces in question, and when I copy it, I'll copy it a very specific distance that I can remember. So for instance, I'm going to move it 60 feet, and I want to remember 60 feet because, well, when I move this back into the exact spot that I want it, it needs to be 60 feet. And of course, you'll see why. So we're just making it a little easier for ourselves so that we can look at this part a little bit more delicately and maybe draw that line that we need a little bit easier, right? So we definitely have those two pieces in question. And to be fair, we could start to just cut away from this too. We could try Boolean difference, and it's worth a shot. I mean, it's not really touching in any other spot except for that spot in question. So let's try it. It's worth a shot. Boolean difference or split. Ooh, typing wrong. However, I want to split from the wall object, so I'll do Boolean split from that. It'll ask for which object. I'll ask for this piece and that piece, and I can't tell if it's hitting that piece, but maybe it is, maybe it's not. Enter. And as you can see, it did something, but not quite. It kind of got it, you know, but we're still have another piece here. Now, to be fair, it did start to make a new piece for us. And here's another trick that you can use is, well, maybe I'm still just stuck. I can't seem to draw that line that I need to wire cut some of this piece off. I don't know, what do I do? I could make 2D it, right? So I can find the exact view of the piece that I need, and there's that piece that I need. So I'm gonna click on this view, do make 2D, and abstract that piece that I need out of it. For instance, there it is. So I'm gonna explode, and I may actually need to ungroup first, because I think by default I do have it to a grouped motion. Delete the things that I don't need, and remake them for what I do need, right? I just need that top piece so that I can use it to cut it. To be fair, I don't even have to use this one. I can make my own polyline, but now I have a guideline. And of course take near off, because that's dangerous. Too dangerous. And to be fair, that was a lot easier. And if I would have known that years ago, I wouldn't have spent so much time trying to draw a certain piece that I need. And realize that I had the piece the whole time, I just needed to look at it maybe a different way. So now that I have that piece, sweet, there it is, three-dimensional. Let's go ahead and move it to the spot that I need it. So in my case, I may need to flip it around a little bit, but let's get it in the ballpark area and click it to something. I'm gonna go ahead and hit shift, keep that straight, and fake it till I make it. So I do know that this is gonna align pretty well here. Sweet. But now I got a piece that I can wire cut. Now, of course, to make wire cut work, I do have to pull it outside of the object a little bit. But let's now wire cut it. Now, in my case, I've already cut that part. So actually, I need to maybe close this and get rid of the top piece. That's okay. I still need this piece, right? But now it's in a spot where it's kind of hard to look at. So I could hide it, complete that piece, and oh, would you look at that? It's actually a piece that I can just get rid of. Or there's maybe a piece actually inside this stair. I think that was actually maybe just the piece inside the stair. Quite all right. Let's continue. So get my polyline going. Finish that piece out. May have to find the view. I got too excited and put it there before I could work with it. When in doubt, edit undo. Not a big deal. We just basically need to complete that little piece first. So I do want to make it easier for myself. Make a polyline and continue the rest of it. Doesn't really matter how far I go out, just because the wall's not that tall. And to be fair, it doesn't even need to be straight. I just needed to chop off that piece of wall. But I kind of do want it to be straight because I'm kind of OCD about things, but let's just see what it does. Get that piece, that piece. Doesn't look like it's closed, but that's okay. I'm gonna go ahead and join it first, and then the command close curve. And it's gonna automatically close it for me, but oh no, it looks like it was actually open in 2 spots. So let's go ahead and fix that. Go ahead and move it, put them together, curve, and join. It's funny, I said this was gonna be the last part for the sake of time, and it's taken me the most time. But I do think it'll be helpful because you'll definitely run into spots where you just don't know what to do. And what I would say is think differently. Do something that you wouldn't normally do, right? Because very often it actually leads to like new thoughts, new discovery, especially with these programs. But we got a piece, looks like it's solid. We could test it, we could type in what and be like, is it a solid? And be like, yep, totally a valid curve with 15 points. And there's all of its coordinates. Anyway, not that we need that, but you can always type in what to see what it is. Now let's bring it back into place. So where is it again? Oh, there it is. And let's put it back into place. Woo. Probably should have recentered onto that object, but that's okay. Into the place of question. And we'll go ahead and rotate it. And I'll exit on that. I don't want to accidentally move one of those dots. Let's recenter ourselves, make that a little easier. Sweet. I remember one of the first videos I saw where somebody was like modeling something for real. It wasn't architecture, it was actually somebody making a yacht, right? And designing all the pieces of a yacht. I learned so much from that guy. And he didn't even draw any architecture. He just like made yachts, you know? So you'd be surprised what you can find on the internet that you can eventually apply to architecture as well. Anyway, just throwing that out there. But let's go ahead and wire cut this now. Now that we got our piece, got it in the right spot, and of course we can even select to the piece that we want. So that's looking good. And of course it's asking, hey, which side do you want to get, this piece or that piece? In our case, that makes sense because, well, our object does have a piece at the bottom and a piece at the top. So I want to go up so that, of course, it gets that piece at the top. Doesn't look like it went through though. That's okay. Let's try again. Wire cut. Perhaps a different direction. Sweet. X direction. Well, it does technically need to go that way and that way. It doesn't seem to be cutting anything. Why not? Do I have a closed object? I'm pretty sure. Oh, that'll do it. So I don't have a closed object. Forgot to close the rest of my curve afterwards. But that's okay. Now we got a closed curve. Let's try that again. Wire cut. And the wrong direction. That'll do it. Oh, come on. Y direction. Sweet. And we'll go up to there. Finally. Beautiful. And as you can see, we still have that piece in there. So we do need to get rid of it, but not too shabby. And obviously you can see that, well, my wire cut didn't get rid of everything. That's okay. To be fair, another way to do it, when in doubt, make a box and slice it. So another thing we can do, because we can always Boolean difference two objects. So if you ever have a really complex object that you kind of just don't know what to do with it either, we can Boolean split it. And we can sculpt with removing the volume that we don't need. Pretty sure I got rid of it. There we go. Yeah, obviously don't need a random volume there. Oh, yep, we got some pieces. Sweet. Now, of course, last but not least, we got to put that back. To be fair, we didn't really change anything about the stair, so we can delete this piece, right? That piece that was in question, and move this wonderfully 60 feet. I'll use my top view for that. Move. And again, 60 feet. Enter. Hold shift and click. And now it's right back into place and of course fixed. So yeah, sorry that took a little bit longer than I thought it would, but you might run into the exact same errors. Now, let's pause for a moment on the modeling process, and really that's what I intend for you guys to spend the next week on, right? Is really dialing this in, finishing the stairs, and working, being patient with it, right? I know I'm kind of going fast, but that's also so this doesn't take like 3 hours, right? But to be fair, it can take a little bit more than 3 hours, especially if you're really trying to dial it in. You're starting to think about the material, how thick it is, does it work, can I put my head through, do I need to just make a little scale figure and put them through there? Maybe, right? However, the easiest way to make a scale figure is just draw a line at 6 feet, or maybe your height, right? If you're 5'4", draw a little 5'4", and kind of start to imagine and empathize with your model, if you will. But let's pause at the moment for right now in terms of refining the model. I do want to start talking about the laser cutter because you guys are pretty fast, and some of you guys, you know, maybe are already even at this spot and ready to start cutting or setting up the files to get ready and cut and everything. So I don't want to leave you empty-handed. So let's start with the topography. So we got that piece, and to be fair, I guess we don't need that anymore, or that piece. Not a fan of deleting stuff, but you know, because you never know when you're going to need something. But for the sake of tutorial, we'll delete it. In my case, I need to ungroup this piece, and I'm going to go ahead and make a copy. That way I don't accidentally mess that up. But to be fair, you'll notice that I just have nothing there, right? And well, I know that I'm going to be strategically putting something in there, right? So don't get me wrong, I could just make this real quick. It'd be really super easy, and the hard part would be, of course, getting my model on top of it to look integrated. So one thing that we can do here first is actually remove anything that needs to be removed from the ground, right? So for instance, maybe not each individual piece, but actually seeing them as a whole. So for instance, this wall, that definitely sticks out, and it definitely seems like I want to remove some of my topography material so I can lock it in just like a perfect piece. So our favorite tool, Boolean difference or Boolean split. So in my case, I want to split the topography, so I'm going to go ahead and highlight all of my topography. Sweet. And Boolean split with that piece. In my case, that wall, and I may have a few walls, and to be fair, you can do this all at the same time. So you can use the columns. Those columns are going to go into the ground. That one is. And yes, again, you don't have to make crosses. So I would definitely make circular poles, or even make the exact piece that I was going to use. If I'm going to use 1/8 dowels, make sure that they're 1/8 dowels to scale. What is 1/4 scale, right? 4 feet equals an inch, right? So 48 feet is what? 6 inches, right? Or sorry, 1/8 scale, not 1/4 scale. So 8 times 6. But yeah, let's go ahead and make sure that we Boolean split all of these pieces at once. The only reason I wouldn't do everything at once is, well, some pieces may work, some pieces may not. For the most part, you can tell though. But yeah, let's get all of our pieces. I'm gonna refrain from my stair real quick. In fact, I think it'd be easier to chop from the stair in this case, just because we have a lot of stair left. So it makes more sense to actually chop that stair up a little bit first and then start to laser cut it. But look, we're just talking about the topography right now, so let's just make sure we get all the pieces that are going to cut away from the topography. Oh, missing that one and that one. Press enter, and it's immediately going to chop that stuff. Now in my case, perfect. Looks about right. I'm going to go ahead and make a copy of that piece, especially while it's selected. Let's see what we got there. Ah, much better. Right, now we're ready to go. And, well, I need to get rid of some of the pieces. Now that's just because I use Boolean split. And I like to keep the pieces sometimes because, well, sometimes I need them, sometimes I don't. But at least in this process, if you do use Boolean split, you'll have to delete the of course, split part, which can be tedious, but I kind of like it because it then lets me know, and I can sort of double check in the process and make sure that everything was cut. You start to see if anything's out of place or anything like that. But yep, even worse, we have to cut it from each layer. But to be fair, we can do that at a different time too. But be careful, like what I just did, I accidentally deleted a part that I don't necessarily want to delete. Maybe I do, it's just looking weird. Man, it really got that face. Right in there. Anyway. But yeah, as you can see, it's almost like we're starting to shape our foundation, and you start to see these interlocking pieces that are eventually going to happen. Now, last but not least, we got to get it ready for the laser cutter. So, of course, I do want to do away with most of these pieces first. And to be fair, once we start to separate them, these anomalies are going to represent themselves anyway, so I don't necessarily have to do this part, but I just think it's kind of nice to start to see the holes that it created. Anyway, and you start to realize, oh man, there's a lot of pieces in here. Oh man, maybe I should simplify my stairs. Things like that. But that's looking pretty good so far. Again, you know me, I like to make a copy, might mess up. And the next thing we need to do is just separate them. Actually, this part's pretty easy. We'll just take the model. And I do want to separate them at least in an orderly fashion, right? Because, well, I'm going to have to go 1, and select the next surface. I may need all 4 views for this to make sure that I'm selecting the right surface, and I wasn't. So I'm going to select that piece and that piece. And again, I just want to be organized. In my case, I'm just going to move things up piece by piece. So next piece, move up. Next piece, move up. Next piece, and so on. Right, and I'm trying to get them outside of the model so that I can make these a little bit easier to work with and make 2D them so that I can send them to the laser cutter. However, you'll notice right now they're very three-dimensional, right? They're still locked in that Z direction. Oh. But now they're much easier to select, especially one at a time. Like I said, it is a tedious part, but it definitely does beat making models and spending a lot of money before you actually want to, or that it's necessary. Because you imagine you do this for a skyscraper, you save a lot of money, right? Thinking about all those parts. Of course, this is what we do with a lot of products, whether it be a car, whether it be architecture, lots of things, right? Of course, we model them first. Actually, one of the first things I got into was modeling shoes, you know, high heel shoes for women, just because it was super interesting and it was very structural. You'd be surprised actually how much science and modeling goes into making a woman's shoe. And Nike shoes or running shoes, all those things. The engineers and the architects behind those 3D models, you better believe they hire those architects. They go, oh, you got rhinoceros experience? Absolutely. Get on board. Oh, you 3D print? You fabricate stuff with laser cutters? You have a job. Oh, what do you mean? I don't have to make buildings? No, you don't have to make buildings, especially if you find boxes a little boring. I personally like making products and furniture, and have made a pretty good living out of it doing so. So there's definitely a lot of options when it comes to architecture. Anyway, we've got our pieces, and more or less you can start to imagine that, well, those are our pieces that are eventually going to be cut out of cardboard, right? However, we can make it way easier for ourselves and just make 2D. Because all I need for the laser cutter is still 2-dimensional lines. So in my case, now I've got my 2-dimensional lines, and I do need to refine things a little bit, right? For instance, well, maybe not so bad, but in some cases it looks like there's a hidden line situation. So I don't want the laser cutter to make random things, but I do want to make sure that, of course, these holes are correct. Yeah, and those are looking pretty good. A little bit weird there, but I'm guessing that's maybe the wall that comes in and the wall that I split and took away. You'll notice that some become quite literally 2 pieces for that layer. So 1.1 layer and 1.2 layer, right? You definitely need both of those. So that one will need some help. But for the most part, the only thing that you really need to know about our laser cutter is that it's a 12 by 24 bed. So I'm going to go ahead and draw that 12 by 24. Now, if I do that, so 12 inches by 24 inches, you'll be like, wait a minute. How do we get this gigantic true scaled object onto our laser cutter that is really only a bed of 1 by 2, right? So the first thing that we'll need to do to this rectangle, and of course my Graphics 3 students know this already, is we need to scale this rectangle to whatever size that we need it. So in our case, we need a 1/8 scale. So I need to do 12 times 8 feet because I can fit 8 feet in an inch, right? If I was doing 1/4 scale, I would times it by 4. If I was doing 1/16 scale, I would times it by 16. And I think I've gone over this a little bit. Again, I do so many of these tutorials, I can't remember honestly what class I teach it to, but yeah, it's the exact same scaling factor. So in my case, I'm going to pull out my calculator. I'm going to go ahead and do 8 times 12, which is of course I think 96. Yep. So I'm going to make a new rectangle just so you can kind of see what the difference that makes. 96 feet, enter. And of course 24, which is 96 times 2, which is 192. So 192 feet. And that's because, well, right, I can fit 8 feet per inch, right? So now what's crazy is we didn't have to scale our model at all. We didn't have to make another model. We didn't have to make a 1/4 model, a 1/8 model, because you guys know in Studio, you could be asked for several different scales of your model. And it doesn't make sense to constantly keep changing things and accidentally be looking at a model and be like, oh crap, I was working on the 1/4 model. I meant to be working on the 1/8 model, and suddenly have to do all of that or scale it again. It makes a lot more sense to just scale the layout, right? Which is, of course, a method that I found from a professor in my master's program. And boy, does that save me a lot of time, because, well, now my model is to scale according to the layout that it is going on. So in our case, this gigantic rectangle in real model space represents actually 1/8 scale for our model. So you may notice not all of these pieces are going to fit on there. So I'm going to need multiple cuts, right? Or multiple files to send. I'm going to guess 3 on this one. There's a couple layers in there. I'm going to start with the base because I think that's, a smart thing to do. But in my case, I do want to ungroup these because it does look like they're grouped. I may need to explode them, maybe not. And maybe regroup them actually as their individual layers, because, well, if I accidentally select this, guys, and I accidentally move it, oh man, that whole layer is messed up. It's not going to work now, right? So do be very careful. What I'd like to do is actually group things as I go, ungroup things as I go. It is tedious, but it does work. Now in my case, I just need to put them on the field, right? So in my case, I should be able to fit a total of 8 pieces theoretically. What's nice about the laser cutter is that we find that it can cut over the same line twice, right? Now keep in mind it's going to burn that material, but it can cut up right to the line. In fact, its accuracy is 0.001 of a millimeter, which is pretty accurate, right? So we can fit most of our pieces on there. And again, I'm just going to move it as necessary. And to be fair, we could actually do something first here before we do that. Otherwise, we're going to have to change the layers here. So in my case, I'm going to make a new layer. I'm going to call it cut. And, I might need a score layer. In my case, I don't need a score layer, so not a big deal. And for the laser cutter, you can either use blue or red. I'm pretty used to red being the score line, but I know at San Antonio College we use blue for the cut line. Is that right? Does anybody remember? Red is cut, yeah. I always just remember it's the opposite of Texas Tech. Doesn't really matter, to be fair, but we do want to be consistent, right? So I will use red, and literally the color red. I don't want to accidentally get something sort of off color red. This does start to be pretty important, right? Especially for the machines we use, because, well, certain machines need exact colors. So I just want to kind of point that out. I don't want to get too advanced because our laser cutter doesn't need that advanced, but like mine at home definitely needs exact 128-bit colors. So yeah, we'll use red in this case, and it just sets up some good habits. But let's go ahead and get all of those. Right click and change our object layer. And as you can see, it didn't do much because, well, some of this stuff is grouped and not exploded. So let's ungroup it, explode it. And you'll notice, well, maybe it did change the layer, but the display color is still stuck on black, and that's okay. So we can change that to red as well. Technically, it will print red, but I like to see it too. So that's a pretty good setup, and we can start to imagine that, yes, I definitely want a circle cut out of my entire piece. Right? Now we can put it on our boards. So this is probably where I don't really need to make a copy, and I don't make a copy just because I want to make sure that I get each piece, and I don't want to accidentally double on my pieces, which I've definitely done before. And again, as long as I'm staying orderly and I know the positioning of these pieces, I can just kind of put them on the board. Not too shabby. But we'll go ahead and do these 4 pieces today. And as you can see, actually that works out. Look at that. Goes up right to it. So yeah, it should work because, well, we have 12 inches and we have 6-inch pieces at 1/8 scale. So not a big deal. It should fit exactly. However, you'll see that we have a lot of leftover space, which, I don't know, maybe some of our small parts can actually take advantage of some of that waste, because that is, of course, what it would become, is waste if we don't use it. So, to be fair, I could actually line these up a little bit better and reduce the amount of waste that I'm going to have to throw away. This becomes very important in architecture, right? Because that's the part of the budget. In fact, that's something you learn in construction very quickly, that you need to order a little bit more than you actually need, right? Because you're going to cut away leftover pieces. You're going to get rid of stuff that you don't need. And if I only calculate the exact mass or something, I may be actually, without a paddle when I come to constructing it. Might run out of material pretty quickly. But as you can see, the pieces are getting smaller and smaller, so I can fit a little bit more. Maybe I can fit them all in one piece. That would be exciting. I doubt it, but maybe it's gonna get very close. And that's pretty good. As long as they're not doing this, you're okay, right? But as soon as they overlap, that's dangerous, because, well, it's going to take away from the piece that you need and take away from this piece you need and leave you with a piece that you don't need, right? So be very careful about accidentally overlapping them. In fact, it's very safe to not have them touch and, leave a little bit of space. Not a big deal, especially since in this case we have some. Now, last but not least, this tiny little piece at the top, and it looks like it can fit somewhere. Now, one thing that I can't do is mirror it. Well, I guess you could, because, well, I guess you could just flip that piece over, right? However, it's going to make a very different piece, right, if I do that. I can rotate it, though, right? And I don't even have to stay orthogonal. If I wanted to do something like that and move it into place, that would work, right? Now, it's going to be some strange leftover pieces, but we'll go ahead and show you that. But yeah, we actually got it all to one piece, and essentially this is what we need to send to the laser cutter. So I'm going to go ahead and highlight all of it. I'm going to right click, export selected, and in my case I want to save it to my USB drive. That way I can bring it upstairs. So I need my adapter real quick. And I'll just save it actually directly to my USB. And this is probably a process that you'll have to do as well, just because you'll see the computer upstairs is a little dated, right? A little fickle. And to be fair, it's not even on the network of San Antonio College, so that makes it even more sketchy and difficult to work with, but we'll get there. So let's go ahead and get that on my drive. It looks like it's still finding it. It's not plugged in all the way. That'll do it. Yes, make sure your USB is plugged in all the way. Allow. Of course, we should see it pop up on my screen. Sweet. And let's go ahead, topo test, cardboard. I really like to put the material that I'm going to use on this, because let's face it, I got it to all one page, but realistically, especially in studio, you're going to have multiple pages, right? And it's a really good habit to go page 1, page 2, page 3, and what material that you want to cut, right? Because to be fair, at San Antonio College, we let you use the laser cutter. At Texas Tech, U of H, UT, they do not let you touch the $100,000 machine, right? And for good reason, right? So very often you're actually sending it to a tech who he doesn't know your model, or she doesn't know your model very well. And it wasn't labeled cardboard. It wasn't even labeled a size or anything, or what it should be going on. And that tech person is just gonna cut it on whatever, right? Especially whatever you labeled maybe on the computer. Anyway, I know I'm talking a little bit towards the future, but good habits go a long way. But topo test cardboard, and of course you can spell it correctly. There we go. export, not as a Rhino 8 file. So the computer upstairs only has Rhino 6. So in our case, we need to save it actually as a Rhino 6 file. So that's definitely important to know. Export. In fact, in some cases, you know, I don't know maybe what I'm going to have to send to or what kind of machine. So very often, one of the more universal pieces that you can do is actually a DXF, which is a part of the AutoCAD family. But again, it's just kind of good to have. So I kind of just want to throw it in there because that will also laser cut as well. So let's say backup. So I don't know what I'm going to get into upstairs. You might not know what you're about to get into as well. So I'm going to save 2 of them. That way, maybe one will work, maybe both will work. Hopefully, it won't be a situation where nothing works. So I'm going to go ahead and end the recording here. But yeah, really the only thing that we need to do here, I want to talk about a couple things. It is a donated machine. If you break it, we don't get another one, which is why I'm working on getting another one for us, right? And hopefully using this room, maybe selling that guy because it's 180 grand. Anyway, hopefully we're going to get this place a little bit better. It took us literally 7 weeks just to get that thing installed. So naturally things at the administration level, they take a long time, right? Unless you can do it all at once with a grant, right? Anyway, have a couple things here. Of course, we have the laser here. You'll see that there's a 2.0 on there. It stands for 2 inches, and it means that the laser needs to be exactly 2 inches away from the material, not the bed. So if I have a really thick material, it needs to go 2 inches from the top of that material, right? Pretty simple enough. In most cases, you're not gonna cut anything larger than 1/4 anyway. So maybe not a huge deal. I don't know if we ever found the little piece that we need, but there is a little spacer we need as well that I don't think anybody ever found. So we may have to measure it manually with, you know, just a simple ruler. However, it is imperative that it is exactly 2 inches, just because the exact focus length is what gives it its cutting power. Let's make sure it's not in here. Oh, we do have a couple of things from over at the CAC. However, they're all outdated, and to be fair, the way that this cuts, guys, is basically a CO2 tube, right? That's filled with CO2 gas and is ignited to basically send a laser to a mirror. It hits this mirror right here, and it hits this mirror right there, and then it shoots it down, right? And then, of course, uses its foci length to cut the material, right? However, it's based on these numbers and sheets and things like that. You'll see that eventually you want to kind of manualize these, and these are Mansky settings from 2017. So it's a bit dated, and to be fair, it's probably not even going to work, right? However, it's nice because we start to see, you know, thick material versus thin material and what kind of power settings that we're going to have to use. Now, the good news is there's already pre-built ones into the software, right? And we simply have to select the material. But to be fair, it's a bit limited as well, right? It doesn't exactly have 4-ply chipboard versus 2-ply versus 1-ply chipboard. So some of that stuff you have to kind of do a little bit manually. Now, I do have another video on my YouTube that's just how to use a laser cutter. And this will hopefully replace that a little bit. But I'm going to leave both up there just in case I miss one out of the other. And we're already missing that little piece, so this is not going to go well. I also have no idea how we'll cut it without that piece, which is probably why he was saying, you know, it wasn't cutting at first until I started doing something, and I think I know what he was doing. He was messing with the Z-axis, which is very dangerous. You can start a fire with this machine. It's very easy to do, which is why there's actually a glass piece right here. It's maybe one of the first rules I should say about laser cutting is while you're laser cutting, somebody needs to be in the room, right? You never just leave a laser cutter, especially if it's gonna, maybe you're doing something that's gonna take 4 hours. You need to sit there and watch it for 4 hours. So don't go rastering stuff, right? Which is good. We don't even use rastering in architecture very much. For the most part, you're probably gonna be cutting and scoring items. Now, normally we have some scrap material, and I was hoping there'd actually be some, but it looks like this is all we got. So I won't be able to really cut my file, but I'll get one piece out of this, or maybe arguably 2. So a few bits about the laser cutter itself is here's that 12 by 24 bed, and you'll notice that there's a honeycomb on this, right? That's the portion that only gets cut. So you'll notice that the border itself, it's good, right? In fact, you can almost use it as like a, you know, a little jig to kind of keep the material straight. It's also exactly 12 inches by 24. So if you notice your material doesn't fit, you need to make it exactly 12 by 24, even just a little bit off, guys. Again, that focal point is gonna cut here because it's at a certain depth, where over here it might not because, well, it's off the bed. Relatively, you want extremely flat material. And let's face it, some basswood is bent up a little bit. What do I need to do? Get some painter's tape and make sure that it's actually flat. It's gonna cut right through the painter's tape anyway, right? And you don't even have to change any settings to cut through painter's tape because it is paper, right? This thing also cuts paper. If you ever wanted to do really crazy origami, I mean, it's pretty cool. I don't know, there's a reason why I love them so much. But for the most part, R0 is right here, right? So you'll notice the machine always tries to go back to its home or its origin, right? Which is 0, 0, 0, just like Rhino, right? So we'll go ahead and put that over here. And as you can see, my material's not very flat, and maybe it's a little bit more flat this way. And I can really get it in there, right? Now, the exhaust is on. Theoretically, it's supposed to be a little bit more powerful than that and actually suck the material down. It's very useful because while you're cutting, what happens if the material moves? Oh, crap, you know, there goes the actual accuracy of that piece. So it's imperative that if you feel like it's gonna move, just tape it down. It's not worth wasting your material. It's not worth wasting your time or the laser cutter time, because to be fair, this CO2 laser I was talking about has more or less only 180,000 hours on it, right? And it does need to be replaced every time, and it is $600 every time there's a replacement, right? So they don't last forever is what I'm saying. So be sure to be aware of those things. There's a reason why Texas Tech, U of H, and other schools don't let you even touch these things. But at San Antonio College, I don't know, maybe we're just riskier or something. I honestly don't know why we don't just hire a tech person to do this all day for you guys. I don't know, maybe the demand's not there yet, but anyway, let's run the machine. Basic settings, you really can't hurt yourself with this machine. I mean, I guess you can if you just started to fool with it, but technically, as soon as you open this, the laser will cut off. Right? So even if you're starting to cut and you see a fire, immediately open it. I know that sounds counterintuitive, like, oh, yay, fire, right? But actually it's gonna cut the laser as soon as you do that, and of course immediately cut the fire as well, right? So again, fire is an issue because we cut paper products, right? So keep that in mind. Same with wood products, plastic products. You can actually cut leather on it. It smells awful, but yeah, leather is flammable too, so. Anyway, let's get that file going, and
you want me to scoot up?
Yeah, if you can kind of just, as long as you can see it.
Yeah, I'm gonna scoot up.
So yeah, we're gonna open up Rhino 6 and essentially open up that file. So as long as my drive is going, and what did I call it again? I got so much stuff on it. There it is. It even says Rhino 6 for me. Sweet. So of course we can double click. I think it might actually open another Rhino. My bad. Oh boy. Hey, you don't want two Rhinos really running unless you have a very strong computer. This computer is probably okay, but it's not good practice. Now the way that this program works, we just need to print it. This is essentially a glorified printer, but instead of printing ink, it's printing lasers. I don't know. It sounds really cool to say that, but that's essentially what it is. And instead of using color, now we're using the amount of power or speed or the amount of pixels per inch, right? So the way that a laser works, it's not like a continuous beam. It's actually shooting a frequency of light, right? And we can control the amount of that cutting. You can almost imagine like it's a saw blade sort of cutting through the material. You can make a dotted pattern because of that, right? And all kinds of things. But it's basically a pulse per inch, which is called PPI. Anyway, get into the technical stuff, but I think it is worth your knowledge. Anyway, so all we have to do is basically press print. So we'll go to File. Oh, let's make that a little bigger. File, Print, by default, it is the laser cutter that you need. To be fair, I think these are all previous versions of this laser cutter that have had to be set up over and over again. Just make sure you're on VLS3, right? 50 dash, and again, it's usually the default, but just in case you need to see it, at least it's being recorded. Lastly, we need to go to the view and output scale, and we need to select window, right? Because we made a window for ourselves, and now we need to set that window to this window. And since we set it to scale 12 by 24, we'll have no issue, right? So we'll select window set, we'll click the boundary of the box, enter, voila. And of course you should see it fill the entire extent of the drawing, right? And we're good, press print. Now you'll notice nothing happened, right? And well, for the laser cutter, it has its own little sort of pre-printing setup, right? So I'll go ahead and we're done with Rhino essentially. And we need to open up UCP. I don't know who named it that, but it's called UCP, right? So you'll double click on it. You'll give it a little bit of time to load. But more or less, it should actually show up what you have. And in my case, it looks like the screen's just really dirty or something. I don't know what's going on here, but I don't know. All my lines look a little bit funky, right? So actually, maybe I need to change something a little bit. In my layers, I forgot to maybe tell you guys this, but we need a specific line for this printer, right? So by default, I'm going to just change everything in the layer. We do need to be continuous line type. And in my case, I know it looks a little bit different, right? We'll have to go to properties and select those lines. In my case, I don't need this outside line. So I'll just get the cut pieces, and as you can see, it just got those pieces. Now, display color, sure, but print color, uh-oh. Remember what I said about this guy? It needs to be a true color, and right now it's set to black, which is why it looked kind of faded in that UCP file. So my print color, even though it's not going to change anything here, I do want to make it red, right? Or again, the color that you need. My print width is set at default, and usually that does work, but actually what's needed, just in case default isn't set to the right default, we need hairline, right? Because this does print at a 0.001 of a millimeter, which happens to be known as a hairline model type, right? Or line type. In our case, it's the print width, but now we're good to go. But to be fair, nothing visually changed. So keep that in mind, that these things, we have to kind of change the settings of those lines. Same process though, we'll do Control P for print. And honestly, once you do the window set, you're good, right? It'll as long as you didn't close Rhino, it'll keep the same piece. So we'll hit print again. Nothing will happen except the changes possibly in UCP. So in my case, this actually controls, so you can actually see everybody's file. So don't print something that you shouldn't print. I can't tell you how many times, especially at Tech, there'd be like a gigantic Playboy logo, and of course it is only used for school purposes. Keep in mind, those are good hours that students not even born yet hopefully will be able to use, right? But as you can see, totally updated. I can definitely see my red lines now, and I'm ready to go, right? But just in case I have to send it a couple of times, keep in mind it'll always be at the bottom. So there's that last one that was messed up. And just in case it doesn't load, just continue to the bottom so that you can load the next one. But that's looking pretty good. And we can zoom in, zoom out. A couple of things that we can do here. So for instance, right now I have a really small piece of material, right? It's not obviously gonna fit any of this, which is why I was saying I'll run it, but technically you shouldn't run the laser on the bed, right? It's a really good way to start a fire because of all the debris that might be inside, interlocked in those little honeycombs. So it's never a good idea to run this, but I'm gonna run it today because, well, I am a professional. I'm gonna stop it, of course, before anything bad happens. But hopefully we can get one of these pieces out of that sheet. However, I can test it first. So you'll see that there's this little focus view right now. And if I click on that and I click anywhere, you'll see that X marks the spot and it's in blue. And as soon as I click it, it's gonna go to that exact position on the laser cutter. Now what's nice about that, and Zion, if you can kind of go to it, it's even gonna tell us exactly where it is, right? So I might go, you know what, I'm not gonna nail any of that. Obviously I have a tiny little piece, but I may wanna actually move it around. You know, maybe I'm just doing a little scale figure out of a very particular piece of material. I don't wanna just like randomly put it there, right? In fact, of course, one thing to also say, this is a very fickle cover. Just make sure that it's always down, right? It happens every year. We have a student accidentally leave it like this. They start moving it, it's gonna crunch itself. Right, so be very careful. It's not actually needed, but it is kind of a nice safety cleaning feature, if you will. Honestly, I think it just makes things dirtier and people don't notice it or clean it. But we can test those things, right? We can go, is it gonna get that corner? Is it gonna get that corner? Is it gonna get that corner? And that corner? And exactly, right? And I can test those things out for myself. And I can even see when the laser is going to hit, right? So I can move this into position and hopefully we can get that piece out, right? So I wanna test it a little bit, maybe test that corner. Gonna nail it. Is it gonna get that piece? Gonna nail it, right? But I think it's pretty intuitive. But again, something you wanna test a little bit first because I don't know, you might be using, I mean, one time we were cutting cherry wood and I messed up big. I mean, cherry wood's really expensive for a model, right? We had to stain it, we had to do all this stuff to it. And then I sent the wrong file on it. So you wanna double check these things because eventually it starts to be money, right? And our time. It takes a long time to cut cherry wood, by the way. Anyway, but that piece is looking good. So in my case, I can't really edit anything here. So I may have to resend the print, but at least I've locked onto the piece that I want to do for this. So in my case, just so I don't burn anything, I'm basically getting rid of the lines that I don't need, right? So just, and I'll leave a couple just so you can kind of see what it does. But as you can see, all the lines are separated. They're all hairline, they're all good to go. And I could do print again just because, well, actually I set up my window first. I accidentally deleted my rectangle, but that's okay. We'll press print. And again, nothing will happen except the changes here in the UCP program. So that's looking pretty good. Lastly, this is where that little 2-inch model will come in handy. Let's see if is there a scale in here? Can anybody see if there's one at the desk, Leo? Any scales whatsoever? No. Maybe this caliper will help, but I think it's in centimeters. God, it's in millimeters. I guess 23.4 times 2. 46.8, right? Close enough, right? Let's get that. Let's see. 1, 2, 3. I'm gonna ballpark it. So I'm probably better at defining 2 inches than millimeters. You try and think in millimeters, man. I don't know how people do that. But I get meters, I get yards, inches, feet. I can do that. As soon as you start talking millimeter, I'm like, what's the difference between 35 and 40? Like visually, you know? That's about it, I would say. But essentially, the little tool that we want to have is not necessarily this one. And to be fair, the way that this caliper works, I can either get the inside of the gap or the outside of the gap. So from like end to end is exactly 2 feet. But as you can see here, it's not going to calculate the rest of this caliper. So not really useful. In fact, what we use the caliper for is so that we can get the thickness of the material, right? And down to the millimeter, because what I'll show you next.
We want to go get a scale?
No, it's okay. Just keep in mind that you do want to scale to get this piece. I need to just find the piece for you guys. If you check out the first video, it actually shows that piece. I might just need to make a new one.
Block.
It's like a $80 piece of plastic. It's stupid. I can 3D print a bunch of them, but I just need to do that. Anyway, we're gonna assume that this is actually pretty close to 2 inches. just keep in mind that that's what that 2.0 is for, that it needs to be 2 inches away from the material. I would just get a scale. And if you have one of like the aluminum sort of floppy ones with the cork backing, those are probably the best because you can lay them flat and you can usually get right to the tip of the ruler. Does that make sense? But it is imperative. Otherwise you'll cut it at full power and nothing will happen, right? And it's because of the focus of that laser. I could draw it out, but it's basically a cone, right? And that intersection of the cone is where it cuts. Once it moves past, well, there goes the cone again, obviously inverted. Hopefully that's making sense. I talk in section a lot, but last but not least, we have a couple of different settings. So we'll click on settings here. After we've already checked the laser, you know, the positioning, the height, as you can imagine, it can be a tedious process. This is the database and materials database that I was talking about, right? So I know it's not very intuitive, but like natural, right? Mat board, that's chipboard, right? But again, it doesn't say chipboard, so a lot of students go, sir, it doesn't have chipboard, right? But of course, it's mat board.
What's mother of pearl?
Don't ask. Mother of pearl is, you can get it in a sheet, right? If you know how pearls are made, basically they stick a little rock basically in an oyster, and that oyster starts to shell it, right? And then you get these awesome little pearls. Or you can do this process in a flat process and you can get a sheet of pearl. We use it on guitars all the time. It's really great. Anyway. But yeah, mother of pearl is another material. You can cut paper. You cannot cut stone. I have no idea why stone is in there. Like maybe you can etch stone, but there's no way you can cut stone. You need a water cutter to cut aluminum or any other metals. So don't stick any metals in this either. It'll immediately reflect and blow up the machine, right? So don't use aluminum. If you're not sure if it's aluminum or not, don't use it, right? I mean, pretty standard. We've never had that issue, obviously, but yeah, you need a water cutter to cut any sort of metal, right? Not a laser because it'll reflect. But in our case, we'll use mat board. Not a lot to go on there, and really this material thickness is all we need, right? So in our case, I can use my caliper, make sure that I have, you know, the right thickness here. You'll notice that it's in inches, so I may need to do a conversion. Again, we don't have the best tools here at SAC, but it's exactly 3 millimeters, I think, 2.8. 2.8 millimeters into inches. I guess we could do that in Google, but for the sake of time, I'm just going to assume that 0.160 of an inch is actually pretty close. I think it is. But anyway. You'll see that there's, at least in the materials database tab, that there's a couple of options. Obviously, raster, I would always skip. And you'll notice that the text itself is in the color black. And that's because, well, the color black controls the raster layer. You'll notice that vector engraving, I want to skip because it's in blue. I don't have any blue lines, so I can skip that too. Now, vector cutting, good thing it's in red because, well, that's red. And I can even decide to increase the power. Right, say it's not cutting very well, even though I'm at this mat board setting and I've got the right thickness, sir, it's just not cutting still. I can add a little bit more power. I would go in sets of 5%, 10%, 15%, because to be fair, if you do 1% at a time, it's like, I don't really see the difference between 12 and 13, you know, and stuff like that. Usually I go 5 because you'll start to see the difference and things like that. But you'll notice it doesn't go very far, right? It only goes up to 50%, and to be fair, 50% extra is a lot, right? So I'm gonna just set it to 5, right? Just to kind of see what happens. I'm gonna press apply, and then press OK, right? So there's the first method. I can use mat board or things like that. I could also go onto Reddit and look up the basic power. So this is a 60-watt CO2 laser cutter. That's really important. I'd write that down because that's some good information on Reddit. In fact, there's people who just have lists of laser cutters and their settings, right? And so that's how we made all those little cards, right? So we simply just write down the ones that were working better online. And for good reason, because if I go to my settings and I go to manual control, it's kind of my favorite, but a little bit more advanced, we can dial in the power, the speed, and the pulses per inch, right? We can also control the Z-axis, but not really important. Actually, you should set your Z to 0 because ours isn't an automatic Z leveling laser cutter. Anyway, keep it simple. We're gonna use the database and see what that performs. I'm gonna press play and we'll see what happens. And as you can see, there's a little flame there. That's normal. That's not something I would open it for. Trust me, the whole thing will become inflamed, and that's when you should open it, right? But something like that's not too bad. To be fair, I probably have too much power.
Would that hurt on your skin?
Hell yeah. But yeah, I definitely have too much power. You see the flame kind of lingers a little bit. Yeah, it's too much power. Or not enough speed. Keep in mind I could go a little bit faster and it would also reduce the amount of fire. As you can see, it's making those little tiny crosses that I put in there. But as you can see, what a time saver, right? And accuracy. If I tried to do that in the same amount of time, you know, I'd be laughing at myself. Now in our case, it's gonna get some of those other lines that I kind of wanted to show you what happens when it just hits the bed, right? Looks like it's getting the rest of that. Looks like I doubled up my lines a little bit. So you don't want to accidentally double your lines, because what happens if you double your lines? It's going to go over it again and possibly burn it more than you wanted it to. But yeah, it looks like I had doubles. But as you can see, it can be definitely a little bit dangerous. See how it's burning stuff down there?
Kind of stinks.
Kind of stinks. Yeah, kind of does. But as soon as it's done, it'll go right back to the 0 point, and you can open it. Of course, take it out. In our case, we have no problem. We definitely had way too much power. It shouldn't be that easy to actually take apart. It should be, you kind of have to work for it sometimes, maybe even score it a little bit to cut it out. But you'll see, not too bad, not too shabby. Might have to kind of peel some of that away. And that happens actually to be 1/16 cardboard. And now, real quick, just to show you guys the manual control, I like to show, you know, the computer graphics class a little bit more than I would show the rest of the people, or the rest of the students, I should say. I do want to show you the manual control, because you can get a little bit more refined results, right? You can also, it opens your palette to a little bit more material as well. So for instance, in my settings, I'm going to select manual control instead. This is also where I can really start to mess with the amount of colors. Now, right now we have it set to where you can only use red and blue. However, let me know if you do need to use more colors. I can make it special, right? But for the sake of ease and so that other students don't get confused, we've simplified it to these three. But black, you can actually control it to do anything. Blue, you can control it to do anything. And red, you can control it to do anything. Which is why I was saying in the part one of this video, that it doesn't really matter what color we choose as long as it's exactly blue or exactly red or exactly black, right? Because those are the three colors that this printer prints. That's it. Doesn't print green, at least not right now. Now in our case, we have red. And you'll see that these actually right now, they're on skip mode. That's good, they need to be skipped. Because we only have red. In our case, it was at 100% power. So what's kind of nice about manual control is if you select something in materials database first and then go to manual control after you've pressed play, it'll bring up the settings that it was actually using in there. So that's kind of a nice default, at least to go, okay, well I had too much power there, so I'm gonna take that down a little bit. And really you shouldn't use 100% power ever. However, our bulb is probably getting on its last leg, so you'll realize that you kind of use 100% power, especially the thicker the material. I really wouldn't cut a lot of basswood on here unless it's 1/16, right? At 1/4, it's supposedly rated for a quarter scale of basswood, but it'll take forever. And it better be something just really small. If it's just a rectangle or something like that, that's probably okay. Right? Just keep in mind it's probably going to take a good 10 to 15 minutes, right? And you might as well cut it yourself. So keep in mind some things little laser cutter makes sense for. If I'm making really tiny stairs or little tiny holes inside something, makes a lot of sense. However, in some cases, just cut it yourself and save some of the hours on the clock, if you will. But we'll turn it down just a little bit. So maybe, I don't know, 90%. And I can always just type it in too. The speed, it was looking like it was going a little too slow actually for me. So I'm gonna go with 10%. The amount of pixels per inch was fine. Usually 500 or 450 is where you wanna be. So I'm gonna go with 450. Keep in mind, the smaller the number, the more of a sort of a tab break that it'll have, right? Keep in mind that it's a bunch of little saws, so technically there's a little bit of material and a little bit of holes. It only goes up to 900, but if I want those pieces to just, fall off like brisket on a Sunday afternoon, right? 900 is what I would want to use. Or if the material is more dense, I'd want to use 900. If the material is less dense like paper, I want to use less, because again, I don't want to burn the paper, and paper is very easy to burn with this. So in fact, if I was cutting paper, I'd probably use something like 120, because it's only gonna, saw that many times. Anyway, hopefully that makes sense. We'll use 450 because cardboard is a lot denser than paper. Even though it is made of paper, it's a bunch of strands of paper. So you'll realize we have to learn a little bit more about the stuff that we're doing, right? The material, the density, the cut, the thickness, all those kinds of things start to come into play, which is what makes architecture so hard. Not only do we have to understand the artistic parts, we have to understand the scientific and practical uses of them. But we'll press apply, press OK, and we'll play again. Now, I don't know if I'm actually in the right spot. I don't think I am, so maybe I should check that first. Good thing I did. Fake it till you make it. Again, I would check the height of my laser. Now, since I'm using the same material and nothing's really changed, obviously I don't have to change the Z-axis. But if I do want to change the Z-axis, check this out. I forgot to show you. So once I do get that little piece printed, or that you need to raise or lower the piece, it's these two guys right here, right? So if I lower it, this is going to lower the bed, right? Not this guy, but the bed, right? So 1, 2, 3, and it moves it literally. You can't even see how much it moved, right? It's a millimeter, which is why that distance and that focal point is so important. Now I moved it 3 times, so I'm going to move it back up 3 times. Keep in mind that if I hold it, it'll immediately start moving as well. But I don't want to do that because I don't have the little piece right now. And it looks like we're close enough to 2 inches that at least something's cutting. That actually worked out pretty well because, again, if that laser's off, it just won't cut. Or worse, it'll make a really big burn mark on the material. But that's looking pretty good. Let's press play. Let it do its thing. And a lot less fire, no? Still arguably there, but again, I don't feel like the material is going to get engulfed. And it lingers a little bit less. And as you can see, did you guys see the material move a little bit? That usually typically means that it cut. If you don't see the material move, I'm sorry. And I will say, if you really enjoy this kind of stuff, guys, we need machinists big time. You know, there's so many machines. We're getting into robots, we're getting into laser cutters in architecture. And if you want an easy $100,000 job right out of master's program, you could. And I know plenty of people who were hired right on the spot, you know, because of their knowledge on these machines and how to use them artistically. That's a really big key, because we can hire engineers all day, but they just make good boxes. They don't test the limits of the machines and, you know, really see what they're capable of, like architects. Looks like it's in the spot where we don't really need it, so I just kind of want to show you what happens when we open it. Immediately stops and goes back home. So keep in mind, like, that's a really good feature, right? Again, if there's a fire, I know it sounds counterintuitive, but open it up immediately and it's gonna get all that out of there. Anyway, let's make sure it cut. It did very nicely. And as you can see, questionable piece of material going on, and it looks like it already had cuts in it. That's why it's just starting to fall apart. But yeah, a little bit more breakaway, right? Not so much the brisket on a Sunday afternoon. So, questions, guys? Fair enough. Hopefully exciting. Yeah. Hopefully you can use it in studio now. Now you guys have all been at least basically trained. You can totally use it in studio now.